All right, we are watching.
Yes.
So let's just remind ourselves of one of the really important ones from yesterday. If I put a dot on the outside of my circle, what is the line called when it touches the circle but doesn't touches the circle but doesn't go into it? It's a tangent line. What do you know about tangent lines and a radius? Right, always makes a right angle. Okay, that means obviously two radii have to be equal. What do you know about these two sides? Also equal. And what can I do with this to make my job easier when I need to find out more information? Yeah, I'm going to make it two right angled triangles by splitting it right up the middle. And that makes these two angles equal and these two angles equal. All right, so that's a really important one from yesterday. Anytime you see a tangent line to a radius, Timothy, are we paying attention? Anytime we see a tangent line to a radius, must think right angle because they're rarely going to write that in for you. They're going to think that you know that information. All right. Then we looked at, okay, if you have a center, if you go to a point and you draw, so let's say that you must have a, what's this line called? Diameter. Okay, I'm actually going to change that so it's less looking like a right angle. Okay, so if I make this a diameter and I do this line out here, if I make two triangles, what kind of triangles have I just made? Yeah, these are, well, that one's obtuse. These are both isosceles triangles, right? So these two angles are equal, these two angles are equal. What do you know about these two angles?
Yeah.
They add up to 180. Okay, so what I'm actually going to do for you is just in case you didn't get it, I'm going to do question 1 from 19.6. Okay, so you should have already done this, but I'm going to do this one for you because that is this exact rule. They gave you one piece of information and you needed to know the rest of it. So they drew a line through the center. Then we have C up here. So this is C. O is the origin as usual, and then we have A and B. All right. I'm going to change the thickness of this because I can't actually write on it like that. Okay, this angle in here was 47. This angle in here, we don't know. So we had to find those three. Where do I start? What do I know from this? Based on what I just said, with this information, what do you know? What do you think, hon?
C or AC.
Okay, AC what? ACO. Okay, so I know that this angle here is what? Yeah, this is 47 because this is an isosceles triangle. If these are both the same length, because they're both a radius, then these angles must be the same, right? So if these are both 47, can't I work out this here? It's 180 minus 47 minus 47. What do I get? Someone work it out for me. What is this? This is 80, 94. So take away 94 from this. So that makes this 86. If that's 86, what's this here? 94. If that's 94, what do I know about these two angles? Tell me how you got that.
180 minus 94.
Good. So 180 minus 94, because we've already got a 94. These are equal, so we just divide that by 2. And what did you say we got? Okay, so that makes this 43 and this 43. All right, so when they give you one piece of information, you should always be like, okay, what else can I figure out? You cannot jump straight to those three angles. You don't have enough information yet. You need to fill out this triangle, work out this as a straight line. These two angles are equal, right? You can do one piece at a time. Okay, so that was 1A from yesterday. Okay, let's look at another rule which gets used a lot. Okay, let's go over here. Okay, so if I have a dot in the center, I'm going to make some sort of arrow looking thing. All right, so if I have like a little arrow looking thing, this angle here is always going to be, boys, are we focused? This angle down here is always going to be twice this angle up the top. So if this is X, this is 2X. All right. So this is a really, really helpful thing to know. Let's have a few circles so we can keep going. All right, so this can look a few different ways. Obviously, we can draw this upside down as well, right? Whoops, that's not how you draw it. Okay, so if we draw it like that, again, if this is X, it's the angle that touches the circumference. This angle here is 2X. I should be having little degree signs, shouldn't I? The angle touching the circumference is always half as big as the angle at the center. Now, what kind of shape is this? It's a polygon. It's not a triangle. It's a what? An arrow is not a mathematical shape. How many sides does it have? It's a quadrilateral, right? So, not a square, my goodness, or a triangle. So an arrow is not a mathematical shape. This is a quadrilateral. There are 4 sides, they all touch and they're straight. Okay, it's a weird quadrilateral, but it is a quadrilateral. So we're going to talk a little bit about quadrilaterals. Now, you don't necessarily have to have one that looks like this. You could have one that also looks like this. But the same rule still applies. This angle here is always going to be half as big as this angle here. All right, so the angle that touches the circumference is always half as big as the angle in the center, right? This is a quadrilateral and so is this. I've just drawn them differently, but the rule still works as long as it goes through the center and it touches the circumference. All right, so all of these points are either touching the center or the circumference, which is really, really important. Now, these ones aren't too bad. These are the ones that people can deal with. There's another one which is slightly, well, not slightly, really terrible. So this one is the one that's actually tricky to recognize. So again, if I have a center here, I'm going to draw, oh man, this is going to be really hard to draw. Okay. Okay, so I've drawn that, but then I'm also going to do that. I know. Okay. So if I do something like this, then this angle, oh no, I've got too many lines. I've got too many lines. I've drawn it wrong. Ah. Okay. I'm going to go from here down here. Over here. Oh, that's terrible already. Why am I so bad at drawing? Like that. From there, I'm going to go up here. And I'm going to go back to this one. To the center. Oh, I'm so bad at drawing this. Down to here. Up to here. There we go. Okay. So bad at drawing. Okay, we're going to pretend that looks good. Okay, this angle here and this angle here are the same. So there is a nicer version of this. Okay, I'm going to draw a less complicated version of that because that was ridiculous. The book has one like that, but I'm going to draw you a nicer version of that. Okay. Okay. So if I do, okay, I'm going to call this the butterfly. Okay. So this is my nice little butterfly. Okay. So if you have a butterfly, the top wings are equal. Okay. Those are going to be the same. This is also a weird version of a butterfly, right? You can actually see that this is the butterfly. It's just got extra bits going through it. But if you have a butterfly that does not go through the center, that's the important part. This, because all of these top ones had to go through the center. These ones don't go through the center, which makes them equal, not half the size, okay? So if you've got a little butterfly, then this is quite nice. Now, do we need to do the drunk butterfly? Yes, we do. All right. So there's also a drunk butterfly.
Wow.
Yeah, that's what I like to call him because he's messy. Drink a lot of tequila, which butterflies should never do. All right. So the normal, lovely, sober butterfly is equal, right? When you get a drunk butterfly, the drunk butterfly has accidentally flown through the center. Yeah, don't drink and drive, okay? That is a really good rule. All right, how am I going to draw this one properly? All right, so now he's drunk and he's whoops going through the center. Oh no, poor butterfly. That's what? Oh, actually, I've drawn it badly. I've drawn it wrong. Oh, I'm so bad at drawing. Okay, go down, over, up to the center. To the center? What am I doing? Why am I drawing this so badly? From here, go across and up, and then go down. Yeah. Okay, there we go. Okay, so the lovely sober butterfly is equal. The drunk butterfly is unequal. Poor guy, he got very, very lost. This follows the same rule as the top. This angle here is going to be 2x, and this angle here is going to be x. So a normal lovely butterfly that's not accidentally going through the center is balanced. If he makes a mistake, drinks too much tequila and goes through the center, then he gets really warped, and the center is twice the side, just like these other ones at the top. All right, I'm going to move this up again so I've got some more space. Yeah. Hang on.
For the lateral, why don't you use other tools? So they're also affecting.
Why don't you use these ones?
Yeah.
Okay, they need to be opposite each other, just like these ones, right? Okay, so let's look at this one here. I'm going to teach you a fancy word, which is really not that scary, actually. This is called a cyclical quadrilateral. Quadrilateral. Okay, all this means is it's a quadrilateral inside a circle, right? It's just a fancy word for a quadrilateral that's inside a circle. Cyclical quadrilaterals can't do anything because they are limited by the circle. That means there are things that we can always know. So if this is A, B, C, and D degrees, right? These are all degrees. A and C always equal 180, and B and D always equal 180. So opposite angles in a cyclic quadrilateral always equal 180. Okay, so this is very helpful information. So let me give you an example of how we can use that to work some stuff out.